So I just read the room here a little bit, find out why everybody's coming to see my talk. How many people actually use Visio? All right, that's popular. How many people have actually programmed with Visio? Actually written software that had Visio involved? Who knows about the ShapeSheet, Visio ShapeSheet? Oh boy, okay. How about programming with using other more modern internet tools like Draw.io or JavaScript-based frameworks that do drawing? Work with HTML5 Canvas, anybody? No? How about working with game engines like Unity or Unreal? Okay, cool. Well, then there's going to be some new stuff here for you, and I think you'll enjoy it. So this is why I think you're here, and I think you're interested in a Visio-inspired native programmable drawing tool. I mean, wouldn't that be cool? And you wonder if maybe you could do it with Blazor. Do we have any Blazor developers here, or people just? Okay, well, you're in for a treat. I wanted to learn Blazor, and this is the project I did to help me. And in the end, I think we're going to have an open source library that has all these capabilities. So I'm planning to open source this for the community. Okay. So this is what we'll cover. What comprises Reinvented Visio? How did that get inspired? And yes, Blazor can do it, and there's going to be some cool examples here. And I'm going to give you some tricks and tips that I've learned when I was implementing it, because in all honesty, I learned Visio just this year. I mean, not Visio, Blazor, just this year. Okay, so what is Reinvented Visio solution? Well, it's all the things that Visio can do, mostly all the things that Visio can do, plus the advantages of modern web apps. Okay. Oh, and by the way, what you're seeing in my presentation, this is a Blazor. This is a presentation written in Blazor. Because I figured I'm learning it, I might as well really learn it. So anyhow. So I want to show you some Visio solutions that I have built in the past. This is nearly 20 years ago that I built these things. But they're all focused on having a subject matter expert actually draw a diagram. And then I would reason over the diagram that they drew, and I would then generate a program that could do the product configuration or whatever task they had at hand. This way I was able to let them specify the rules, and as a programmer I tried to put myself out of work and let them specify the rules, and actually as a result many of these applications have had a lifespan of 20 years or so because they're able to create their own rules. So one of the products we built was a knowledge capture system for product configuration. This was used by a large multinational hospital chain. Their company makes hospital equipment. What they liked about Visio is that Visio could do measured drawings, so they could lay in a floor plan, drop Wi-Fi shapes that represented Wi-Fi, and as they dropped those shapes would configure the equipment that they needed. They would calculate the labor to install that shape. They would calculate the lengths of the wires. They would put equipment in the bill of materials, and you'd then produce a bill of materials. So that's the kind of thing I want in a web-based version of Visio. Another project we had was a customer who was producing tires, and they need to plan all the molds that had to be designed for all the different sizes of tires. So what they did is they laid out a project plan, and in the project plan they put rules about what sub-projects should be created, how things should be sized, what additional components needed to be there. And when they ran that project plan for any one of the product lines that they built, it would generate Microsoft Project solution for every one of the steps. So one of my favorites here was a 3D wiring application. Actually had people draw schematics in 2D. Then they would put equipment in racks from the front view. Then they'd put equipment in racks from the top view. And they'd lay cable trays over top of it. And so what the program then did was reason over all of the schematics, figure out what the real wires were, and route them automatically. And it did it perfectly every time, except one time. Guy comes in from the back room and he says, all these wires are too short. And the engineer guy looked at it and said, no, these wires are supposed to go through the floor, not through the ceiling. You've got your drawing upside down. It all worked. So what's nice about that, though, is we introduced the 3D capability, because I'm going to tell you, it's so much easier to see if it's right than calculate if it's right. So building the 3D part was actually worth it. So another odd application we got involved in was legal decision management. I don't know if I'm not a lawyer, but the law is broken up into many smaller arguments that have to be assembled kind of with and, buts, and ors to actually prove to win your case. And so here we actually built a solution with a law professor who was a Yale-trained graduate and well thought of in the industry. He helped us design this solution where he would document how the law was supposed to be reasoned over and then put cases in to do that. So you might ask, how does a mechanical engineer meet such a brilliant lawyer that can help with the project? Well, I married his sister, so that helped. Anyhow, and then here, as a mechanical engineer, this is one of my favorites here, is we actually did an integration to SolidWorks. Does anyone know SolidWorks, a CAD solution, right? So they can we actually asked the SolidWorks parts to extract the parameters that were associated. They would come into Visio. We would then draw diagrams that said, this parameter is this value under these circumstances. You then execute the model, and you'd watch SolidWorks jump through hoops, assembling and sizing all the parts. So that was a lot of fun. So to me, these are what you can do with Visio. These are Visio-like applications. It's never just a drawing tool for me. And my customers love these tools, but when they wanted to go to the internet, and Visio just wasn't ready to go there. So that's what's inspired me over the last couple of years to go back and reinvent Visio using web technologies. And maybe you guys have used some of the web technologies you see here. And so every Christmas or so, I say, let's try it again, what's new? And I learn a new technology and basically call the library Foundry and just keep working at it till I get something that looks like those Visio applications. So the current iteration is here with, I call Foundry Blazor, and it's with HTML5 canvas and 3JS for 3D graphics. Okay, so here's the approach that I take to learning. You as developers probably have something similar. But when I pick a new technology, I go back to a domain that I understand, so I'm only learning one thing at a time, and then I just get started. There's just genius in beginning. Just try it and find an example to do it. So I call that implementation-focused learning, where you look at learning in either learning a new technology or learning a new domain. Those are all things that we have to do as developers all the time. I find myself always learning new technologies, and I find myself getting excited about what it is I can implement in that new technology, and I challenge myself in very small 3-hour increments. Can I get it to do this? Can I get it to do this, right? And I just work the way. So what you're seeing today is something I started at Christmas in stolen hours on the weekends and at nights, okay? So, I was having such success with it, I thought I'd apply to NDC, and now I'm here. So there you go. So the current Visio Reinvention challenge here is, can we get it to be programmable? Can we create custom shapes? Can we use glue to represent objects and how they're connected? And can I make it happen as a drawing surface that perhaps you could use in your own applications just by bringing in a NuGet package? But now I want to add all this good stuff that's everybody expects in the web, right? Animations needs to be web native. We want the model and the shape to be separate so the data doesn't get mixed. I want multi-user collaboration, and I'll show you how it works with SignalR. And of course, a 3D environment. Okay, so the Blazor Advantage. Why can Blazor do this? Well, what's cool, first of all, it's all .NET. And we all know working with the latest part of .NET, Mads keeps advancing the language. We keep loving what he does with it. So .NET has this object-oriented side, and it has this functional side, and they both work well together. And you'll see that in the model. In the .NET ecosystem, you'd be surprised what open source libraries there are. Probably not. You guys see them all the time. And then the cross-platform. I can make it run here. I can make it run in Linux. I can make it run in a container. I can make it run in the cloud. But then Blazor builds on top of that with its extensions, so I can now use C# everywhere, up on the server, up on the client. Okay? So, and Blazor does a very good job doing the interops over top of JavaScript and HTML and WebGL. Now, we're not going to dive into those in any of the talks, but there are a lot of talks previously at NDC and probably at Build this week on how those interops work. Great set of third-party controls, and if you've met the people on the Blazor team, if you've watched any of their presentations, you can see that they're thinking about the future, and it's going to be a platform that grows. So with that, let's just do some demos here. So again, remember, this is a Blazor app. This is the environment that I've built so far. This background is a page that it's actually drawn on. And I want to point out here in the upper right-hand corner, this is an HTML5 canvas element. And this is the frame rate that it's getting when it's doing it. Now, I was developing this. It was only getting 30 frames a second. So is the electricity faster over here or something? But it's doing well. I wanted to point that out because I want you to pay attention to what's going on with the frame rate. I always have this up to tell me what the performance is. So as I make modifications to the program, I could see, did I do something to affect performance? And the other thing I added to the solution was if I'm doing something on the canvas that's affecting a calculation to be made before it renders the next time, it marks that area up there as red. So as we do demos, you can look yourself and see that, okay? So let's just see. So this is a pan zoom window. It's very common in getting things started in Visio. Over here is a 3D environment that we'll talk about before or later. We're not going to talk about before. So so with that 3D and the pan zoom environment here, I can do some very simple things like just add my favorite blue shape. It probably wasn't a good idea to make that blue and have the demo have a blue shape. But so I can create as many blue shapes as I want. And, you know, as I click on one, it changes to the other. I can select them in a group and move them around. I can certainly create an arrow shape. That's very popular in Visio. You know, I asked ChatGPT to create an arrow. It made this for me, okay? So I think if you make arrows for a living, ChatGPT is not going to take your job. So we'll see some other things, though, in the aspect. So the arrows were important because I needed to say, well, how's glue going to work? So here I've built an environment where glue holds together, okay? And then once you build 1D glue, you just got to build 2D glue. So there's that UPC connected to the bottom. It's glued. I cannot move that. If you're going to glue something, you might as well push the timer through to it. And so now I've got animation, or a lot of different ways to do animation. We'll talk about that. And we'll get into some of these other things. So this is just the general environment. It looks pretty simple. A lot of things are going on there. I do want to show you one of my favorite things. Why I was doing it, I'm an old guy, so I was inspired by the David Bowie song, Let's Dance, and I just built this crazy animation that just moves shapes around a random area. So all these elements are here. I was able to try with all these things, and now I'm going to show you under the covers about how all this stuff works, and you'll then have a very good understanding of Visio and how all the components fit together. I'm taking you from the ground up. This is what I call the part when I was writing this presentation. This is the part I call the montage. Okay, so just imagine learning everything you need to learn for the end of the movie to be good. Okay, so here's the project was inspired by Visio, and because I had used Visio a lot, but more importantly, I didn't want to have to learn a whole new set of nomenclature, so I just took the names that Visio used and used them when I built my own application, and I'm hoping that when you guys build applications, that will work for you. Whatever you learn from Visio, you can go ahead and use it. So the Chord of Visio is the ShapeSheet, and the Chord of the ShapeSheet is this page here, which is the transform matrix. So this is the matrix. Well, it's not the matrix, but this is the part that most people get nervous about, and I'm going to ease your pain there. But you can see that the transform matrix actually calculates the width and the height of the shape, the angle that it's at, where it's placed on the page. That's the pin X and pin Y. And then the loc pin X and the loc pin Y are where the center of rotation is. In my implementation, I don't worry about flip X and flip Y. They have a tendency to be reflections and not so important in the types of applications that I built. But here, what was nice about that is, as preparing for the talk, I was able to just Google a slide from Visio to say, what does that mean? And pop it in here. So this is what that means. So that's how they all work together. But here is .NET code where I create a new 2D matrix, and then I fill that matrix with the pin X, the pin Y, the rotation. I had to calculate to radians from degrees. And then a mathematical formula which says where the reference point is. So that's one method just to get the matrix off of the shape. And then when everything's rendering and you hand it to the Canvas 2D context to draw something, I have to push the matrix into the context, and that tells the canvas, go over here and start drawing. Go over there and start drawing, right? So that's how you get a lot of things to draw wherever you want on the canvas, or one technique. Now, what Visio also did was they designed a geometry section where you can put in any kind of geometry you want. This happens to be geometry for an arrow. And you can see here that the geometry is set up by having a bunch of move and draw commands like turtle or these other kinds of languages, move to, line to. And you can see that it's all parametric based on the height and the width, right? So all the drawings that are in Visio mostly happen inside the shape, and that's how they make that happen. Okay, so what that then allows me to do, here's some actual .NET code that I wrote. I wrote function methods to actually draw stuff to represent the geometry. So you can see how simple draw a box is. You just draw a filled rectangle from 0, 0 in the upper left-hand corner to the height, width, and depth, to the height and width. And then draw box is without fill, and then I have a great draw circle here. Then I got tired of doing that because that gets complicated. So I asked ChatGPT to draw a square, and this is what it came up. I asked it to draw a star because a star can be complicated. And this is what it came up with for me with code, and that one worked. So bad arrow, good at stars. But you can see here, though, that it uses the X and Y data exactly like this up here, right? So I don't know, maybe it read Visio in the background. So let's talk a little about drawing and rendering and the difference. So here I have 3 separate shapes here, and I ask each shape to render its details. And in the process of rendering its details, it has an option to call a function, any one of these functions here, to draw whatever it needs to draw. And you can override these functions dynamically because they're functions. You just push it into the shape. So, and then you can stack them up. So you can see here that this is drawing the shape draw, and then it draws the hover draw over top of it, which is just the red line. And then I get this selection draw, okay? You also notice there's another method I can call here called context link, and I can do that just before the transform. So what that allows you to do then is tell this shape to glue itself to another shape, because you can write a function that moves that shape to you or pushes it away at any time. And that's something that, that just showed up from using Blazor. So I went on to go and build the rest of the stuff associated with Visio drawing. So this is a very common nomenclature. Visio drawing is made up of many pages. The pages have many shapes on them, and the shapes can have subshapes on them as well. And the shapes are classified as being 2D or 3D or whatever they need to be that action. Now, in the early days of Visio, they didn't have real objects that represented the shapes. They just had another section of the shape sheet. And so you would get this kind of object-oriented programming by checking to see if that feature was there or not, right? So what we can do now in the modern age is we can inherit and make classes. And I think I've struck a good balance between some things that are functions and some things that are classes. But what I like about this now is that you can not only have the base class of 2D and a base class of 3D, but now you can have parallel shapes. I have a 3D shape when I go to 3D. I have a 3D text when I go to text. I have a page in 2D. On 3D, I have a stage. So it's very parallel in the models. Now this is how Visio defined a 1D shape. And what's different about a 1D shape than a 2D shape is it's given these two extra parameters here of the beginning and the end. And that's where you would attach and glue. That's how it calculates something. But you notice that it has formulas now for the pin X and pin Y, which is the center of where those 2 points are. It also has the width of the shape that's calculated using Pythagorean theorem. And it's actually figures out the angle based on the tangent. So perhaps you didn't know this, but when you were drawing with 1D shapes in Visio, they were really 2D shapes hiding from you with a different drawing method. So what's nice about that is you can use that coordinate system when you're building something special. Okay, so glue. Glue is very tricky. And I'll just walk through the steps here. Glue is kind of an invisible element that connects a 1D shape to a 2D shape. The 1D shape owns that glue. So, for example, if I move that green shape, that's going to tell that green shape to invalidate its own matrix property. So it's going to talk to the glue that's shared between it and any other shape. In this case, it's just one blue shape. It's going to talk to that glue, and that glue is going to talk to the shape who owns it, the blue shape. And as a result, the blue shape will invalidate its matrix. And on the next rendering or draw cycle, they will recalculate where the end of that arrow should be. And it looks like, and that arrow then jumps to that place. So it creates this feeling of glue that everything's connected together because of the render cycle happening all the time. And you can move one shape and it can affect others. And the chain is smart enough to stop. So, okay. So the other part we needed to add to the Visio was Visio had stencils and ways for you to extend that. I've built this application so you could extend it yourself. All of these menu items all of these items over here are us jumping into these different extensions. And from those extensions, you can access any of the APIs and influence the drawing, okay? So usually what happens when you get things talking to each other in a loosely coupled mode, you have to set up a PubSub technique where you throw data out and whoever's listening to it will affect that. So that mechanism is built in, and Blazor actually has a toolkit that helps you do that as well. So we're using that. And now we get to the rules of rendering. So this picture's very detailed, but I'll give you kind of a high-level thing of what's going on. Remember seeing the rendering cycle up in the upper left-hand corner, 70 frames a second or whatever? That's only happening because the canvas is sending us a message. It says, I think I can do 70 frames a second. Oh, wait, I can do 30. I can do 20, right? It keeps changing. And that's that sequence of events that are coming down from the top. At that point, I have to hand over the power. I have to hand over my render routine to the canvas, and it draws the picture, okay? So that can take different lengths of time here, but, and you'll never get an event that's right on top of the other one. So what happens is, in between the time, we have to update and change the model, like if the glue changes or anything like that. So if an event comes in and we just change the model, that's great. If we get multiple events, that could change something, which can change something else. As long as all that work gets done before the next render cycle, we're great. Sometimes an animation comes in, and now what we have to do is kind of quickly change some things just before we draw it. So the animation is driven by the drawing cycle. But sometimes you'll get events that show up while you're drawing. Okay, so what you got to do with those is just queue them up and then save them for the next drawing cycle. So that's the magic of making it so that the application doesn't stutter when you're starting to move these shapes around. And that was actually, I started building it, and I ran into that problem, and that's the solution I came up with. Just small, incremental. Make it work, make it right, make it perform. So here's an example of the events coming through as I'm moving one of these shapes. And you can see not only is it moving all the things that's connected to it, but it's also moving itself in the little view window as well. Okay? So Blazor can do this stuff, but here's the ultimate goal of what I wanted to achieve. I wanted two people to be able to collaborate together and create an own drawing, and probably in 20 minutes we'll see that. Okay? So what happens is the dark figures here on the page represent the people. They work with a tool, like moving something with a mouse. That's sent to these Foundry API services, which then draw on their own canvas, and they package up what they did, just their little message, pass that through the command service. The command service hits against SignalHub. It's a duplex mechanism, so the data can fly through either direction. It goes to the other hub or someone else who's listening. It gets decoded in that person's command service, and that command service then draws on the screen. The drawings are kept synchronized, and the effect is that the other person's looking over your shoulder while they're drawing. Okay? So with that, I'm sorry that was a lot, but that gives you the background here. Let's do some demos and let's look at some scenarios. So here's the set of demos that I have. I hope to get through them all. Definitely want to hit the collaboration here at the end, but there's some good stuff along the way. So let's talk about hit testing. Okay, so the quad tree is a technique that I learned about when I was doing this version of my implementation. It's a fast way to speed up the hit testing. And what's important about a quad tree is that a hit test is you finding an object under a mouse cursor, okay? And you don't want to do something where you just look through a long list of objects and saying, are you there, are you there, are you there? So it's a very common task. Yeah, I got to figure out how to do it quickly. And a quad tree is a data structure that divides the page into smaller and smaller pieces as it needs it, so the search can be fast. Think of binary search in a visual way, right? So when I was doing this, I couldn't imagine how I did it. So what I always do is I always create a visualization that helps me debug it, and it saves me a lot of time. I don't like to pour through logs and all this other sort of stuff. So let's just take a look at that real quick, a quad tree in action. We'll bring out our ring shape. You can see here how quick the hit tests are, that it finds things. Okay, you also notice that hit testing doesn't influence the frame rate over here. Let me move some of these around just so we can get it. And then I will turn on a visualization of the quad tree and hit test. You can see here now as I actually move elements around, things start to divide themselves up so that my hit tests are quick and efficient, right? So when that actually worked, I was surprised a bit. But I also then wrote a little routine that tracked the mouse, so I know exactly what the data was that I was sending in. And this way I could learn what would happen if I created a rectangle that didn't fully enclose the shape. It wasn't selected, right? So that helped me learn more about how quad tree and hit testing works. So let's look at some more of the details. So here you'll see in the code, you'll see that the quad tree is a recursive algorithm that just keeps making more of itself when it needs to. And the subdivide makes it up into those 4 quarters. And then when you're looking things up in a quad tree, it finds those objects and puts them on the screen. So that's basically how the quad tree works. Let's look at some other code examples. Okay, 3D modeling. Well, I know I needed 3D modeling. So what you do in the .NET community is you go look to see if somebody's already done it, because that's a lot of work, believe me, right? So I went out to look to see if there was a 3D model available. And what I knew is that Blazor had an interop, and I was just hoping that someone connected it to 3JS. And then I could leverage the text mechanism here when 3JS was rendering. So I'm not trying to build a video game here. It's about building the right tool for the job. I just want to have a 3D rendering of models for all my CAD things. And I was looking for an open source library. Well, I found one from a man named Roman, who is living in Ukraine right now. And he was willing to help extend the library, but as you can see here, power goes off for 2 days at a time. So what he did do is he did provide the open source code for me to continue with the project, and we've added more capabilities to it. We're going to share it back to him. So it's a great community, and it's going to help you build Blazor projects. So here's a car. I went out to the internet and just got a Ford Mustang and bring that in. And I want to show you how this works. Looking at static pictures of 3D stuff is silly, right? Right. So let's go look at the 3D world. Okay, so I now have this gamer cab here, and I can first just to show you, I can bring in all sorts of primitives that are part of that application. So these are rectangles you could set up with your own parametric value. If you want to make 3D bar charts, go ahead. This is the tool to do it, right? Also here in the arena, let me restart this. So in the arena is, I can also bring in GLB models, right? Now the trick with these models is they got to come off of the internet. They got to be loaded in that way. So what you have to do is ask for the model to be loaded and then wait to hear about it and then go ahead and render it. So once you figure that out, you're able to then bring in literally anything you can find on the internet, right? I cannot guarantee that they're all proportionally the right size. That's your problem. The other thing that we learned as we did this is well, I always like to stress things out, push it as far as I can. So here I came up with a technique that is going to try to load 1,500 jet fighters to give that T-Rex a run for his money. This is running on a machine that does not have a GPU. Okay, so you could get much better performance on a more capable machine. But just to go look at some of the code here for this in this section. And I'm really, okay, so look for some of the code in this section here. Basically, we ask the models to load themselves, the file name, and ask the models to load themselves. And then It builds a 3D shape, which is that file. That shape gets pre-rendered, called on it, and back in the render cycle, when the pre-rendering sets up the parameters with the X and Y coordinates, and then, on a separate thread, when it comes back here, we put it back into the model. So we figured all that stuff out for you, that as well as cylinders, spheres, all the other types of things that you would normally do in a 3D model. Okay, so let's move on to the next sample. Boyds. So Boyds is a simulation of that I use for stress tests. Does anybody come across Boyds before, or this technique? So it's a simulation of a flock of birds. Okay, so the simulation of these flocking birds shows the impact of a large number of shapes on performance. So this is a good way to test if my modeling environment is performant. And what else I like about this is where I separate the model of the bird or the Boyd from the actual shape. And so that's important for all these other kinds of implementations I want to do later where I have the models separate, so I can test that as well. And then the Boyds, what happens is every animation cycle, the Boyds recalculate what their positions are and how they fit in the frames. So to kind of break that down, this is the way I used to do it before, is put the knowledge of the Boyd in the shape, and it's trapped in there, and I could never extract and reuse it. I wanted a system where I could just make a .NET class that I already had and attach it to the model. So here, we were able to loosely couple that. So here's my definition of a Boyd, and I happen to create it in 3D, random 3D location in space. And here I'm using it inside a shape. Now what's different about what you're seeing here is that all these Boyds are being rendered when the shape's being rendered. They aren't individual shapes. You can do that by creating a new class that inherits from shapes, adding a draw Boyd method, okay, overriding the render detail method for that class, okay, and then write the code that draws the Boyds as it's needed. And so this is a very efficient way. If you need to draw a lot of things at once, you can put it inside of one shape or in the canvas. Okay, the other technique is to break them free and have them all draw individually. And under these circumstances, what I do is I associate the Boyd to the pin X, pin Y of the context link of the shape. Remember I showed you that before? So this is like gluing a model to the shape, and now every time the shape renders, it can find out what the Boyd's up to. Okay, so let's look at that one real quick. Boyd's page. Okay, so here's Boyd's moving in a shape. And you notice here when they're just sitting here, they're still moving. We aren't getting a frame rate change. Okay. If I add more, I can add more Boyds to that shape. But now I can actually ask the Boyds to become individual Boyds. And now you can see you've got this continuous frame rate as they all change and they're all selectable. So it's kind of up to you as to what you want to do with how you would implement your shapes. There's also another interesting aspect of this. Let me refresh the model, where I have the stage associated with the Boyds. So here, if we create some Boyds, let's add some more different colors, you can see that, there you go. It always, sometimes I don't know if they're going to be there. Okay, so I'm glad to see they're all here, right? So there you go. So 2D, 3D Boyds, that helps you know that you can have a model separate from your visualizations. And this is great. If you have existing .NET code that is modeling something and you want to connect it to the platform, you can just connect it that way. Okay, so that's Boyds. Okay, menus and user commands. Well, what I did here in this part of the application, what you want to do is use the shape model to also represent the menus that are going to be in the application. Why write that code twice? Okay, And what this allowed me to do then is create, have the menus either render themselves as traditional menus or on the canvas. So so your basic menu options is really just a dictionary of names and commands, okay? But here I have a tool, an API that allows me to create that menu in terms of menu items and buttons. And then I can either ask that menu to draw itself on the page or draw itself in the application. So let's look at that in real life demo. So let's clear the page here. So here's the menu from clear to let's dance, okay? This menu just creates the copy of the other menu. And now I can apply animations or manipulate it around, but I still have all of the features that we all love from the previous application moving around on the screen. Okay? So that's how the menus work. Just jump back to the code to see the last part here. The menus can also be drawn up here on the top screen. All you really have to do is loop through the menu shape items and create HTML items to represent each of them, and now you have both mechanisms. And that's particularly convenient in the more modern version of Visio, where if you're drawing something, it was really hard to go back over to Stencil and grab something and pull it back. So now you could actually have actions that would draw menus close to where you need them to be drawn, and you can go ahead and click those features. Okay, so that's the menu code sample. One thing I do a lot is lay out trees. You're always laying out trees in the thing. So what we want to do is create a class of. I want to create a class that wraps shapes and orchestrates their layout. And that's the best way to do it. So trees are these hierarchical arrangements of shapes that are all over the diagram. And I want to automate the process of you drawing a tree, because no one likes to draw them. If you add something to a tree, it will relay out the tree in that mechanism. You can control that as well. So what we did is I built my tree layout class, gave it a parent and a list of children trees, and then you basically load the tree with your model shapes, and then ask it to lay out according to horizontal or vertical rules. So let's look at that as a demo. Let's clear the application. So on the composition screen, I can create the workspace demo. And there it's moving. Let me get it in a good place. Let me turn on, again, I always turn on the visuals to tell me what's going on. So here as I close the tree up, it's smaller, right? Open it up again, it's calculated where those parameters should be. So the algorithm for laying out the tree becomes simple once you build that wrapper around it. And a lot of the details really just come down to some very simple constructs. First, you calculate what the size of you are as the most leaf node, and then you work your way up, asking how big you are with your children, and so on up the tree, depending upon what your style of layout is. So once you calculate where everyone should be, then you decide how to move them on in the space that's available, and then finally you loop through all of the trees, all of the tree elements, and you connect them up with the wires or cables, whichever way you want to do it. And so, very simple, quick algorithm, you can generate trees of anything in here, vertical trees, horizontal trees, whatever you prefer. Okay, so now we get a chance to see 2D shape glue in action. So 1D glue requires an object to be glued to a 2D object. Okay, so the glue, the non-renderable part is the glue, and it sits between the two objects. So when a target is moved, the other target moves, or the thing attached to it moves to stay connected and keep that constraint in place. So we talked about the glue before and how that works. So this is what it takes from an API-wise to glue two things together. You create the green shape and the orange shape and put them on, move them to a certain location. I create the 1D shape. I make it an arrow. I'm giving it a special routine to draw that arrow. And then I'm asking that arrow to glue the start to shape 1 on the right side and glue the start to shape 2 on the left side. Okay? So once you have that mechanism in place, that works no matter how much glue is on the main shape. And remember, you moving something forces everything else to recalculate, and that has to happen between the render sequence. So the last part is just what does it take to glue a shape. Once you ask a 1D glue shape how to do something, you create that invisible piece of glue, you mark it, and you glue it together, and then you tell through this command that it needs to recalculate itself. Traditionally, that's called smash or recalculate, but that's what we implemented in the system. So again, if I go back and look at the demo for this, clear off the screen. Okay, so I can get my 1D glue shape and move it around, or this other shape that I call the Tug of War here on the stencil. Right. So this shape here was two shapes glued together and connected. As you see, when it came into the screen, I had it animated to actually help me test the glue. That's my automation technique. I drop a shape, animation triggers, the two shapes pull apart, the one follows it in the middle. So that's how glue works, and you saw the mechanisms on how 2D glue works as well. So let's look at the other coding samples. So with that kind of takes me to actually my favorite piece of code in the whole system. If you guys have been working with the new versions of .NET, C#, you know about the pattern matching mechanism. Here, because I'm sending events across the system, I can then write a pattern matching sequence. Let me get it on the screen here. There you go. So I have a switch statement here that switches based on the type of event, the type of key was pressed, and whether the alternate key or shift keys are down at the same time. As you can see, just matching those patterns, it calls the right function inside the system. And I can grow this, and you can grow it too, just by adding more patterns onto the match. You build your own keyboard mappings. So, okay. So with that, we're ready to talk about collaboration. And to really understand collaboration, you probably want to know a little bit about SignalR and how that mechanism works. So what we did is we built a command service to broker the SignalR messages between any client that's connected up. So you saw the diagrams before that we had the tool service that converted things into the Foundry service. The command service then builds one of these messages depending upon what happened. Was something created, destroyed, glued? Did a model change? Did a parent change? And we grind that all up into JSON and send it to the SignalR hub. Whoever's listening then can decode that message and make that happen on their server. So that message was not really that complicated to build. Here's the message for move. You just set how it moved and manage. What we just had to do here was manage a payload, which was nothing more than the glyph or the object that got moved. So that's how you kept the two things in sequence. Okay. So on the subscription side, internally to every drawing surface, we are subscribing to mouse move events, the glyph events, the creation events. This is where we subscribe on the command service and then translate it into data we can send across to SignalR. Okay? And then that same command service also subscribes to the SignalR hub, captures that message, and then calls the actions internally. And so what you end up getting is this kind of marble event diagram where a very simple action might just be translated, immediately sent, but a sequence of like mouse down, mouse move, mouse up will be translated into this is what that means. The shape is now here, right? Or there might be a thing where you have a control key and a drag, and that means resize the shape. So there's what you want to do is have a kind of a second layer language, or we have a second layer of language that we can keep track and actually recreate a drawing from all the sequences that are sent. And then the SignalR hub, rather than have you guys develop it, it's actually built into the system. You can just ask it to be plugged in to the hub, and it will generate and it will do all the messaging for you. So with that, we're going to take a look at collaboration. So, like I said before, this is the test that I came up with for collaboration. I actually built this animation moving the two parts because I wanted to know that would actually work before I started debugging the SignalR part. So at least now I know if I move two shapes apart, things will stay glued simultaneously, okay? So that was the way I wanted to achieve the test. And then here's just a little glyph that I can have first catch messages of somebody moving a mouse across the screen or somebody actually moving a shape across the screen. But with this now, we're going to do the SignalR demo. Okay, so let me clear this out. And so the first thing you need to do is you need a partner to work with. So I do that by creating up a new workspace here. And let me just put these next to each other. Okay. Now the workspace, I put the name of the workspace over here on the right side, and for some reason I named them after beetles and the compass direction. So I didn't get, let me do this again, because it looks like, as many times have I done this, for this to be the same guy each time, not good. Okay, so let's try another launching here. Okay. So who we got? Paul. Okay. Paul and Ringo are going to play for us today. So once you have the two surfaces, the next step is to start the hub. Okay. So now the client hubs are started on both applications. They should know about each other and they should talk to each other. And what happens is this very freaky effect of the mouse moving on the other side. So you know who you're collaborating with. Okay. So with that, let's have the Tug of War start. And at this point, you're going to have to trust me because I only have one mouse on one hand, right? But I've done this Tug of War with friends across the internet, and it works well. But I'm also going to give you guys, this software is up in the cloud, and if you want to try it yourself at the party, all you have to do is go to this URL, Visio Canvas. Oh, no, not that. That's not the right one. Okay, this one. I have the version up in the URL, and you guys can try it yourself. I think it's this one. No, that's not that one. Here it is, right? Visio 2023 Oslo AzureWebsites.net. So you can do this with your friends. You're not gonna hurt anything. You're not gonna break anything. You can play together. You don't know who else is going to be on there. There is no authentication to keep it separate. But what's the worst you can do is just make some shapes. So anyhow, I hope you enjoyed the talk. I enjoyed putting it together for you. And if there's any questions, I don't know if we have time for questions, but I'll certainly be at the party and happy to talk to you. So thanks a lot.